All right. Oh. So, we will kind of work through the rest of Module 9 today. Before we do that, I want to mention a couple things. So one, that Canvas discussion, the third one is due at the end of the day tomorrow. I kind of updated the language in it as a reminder, but the syllabus states this. Every Canvas discussion we have, you need to do what? An initial post, right? And in each one, I give you some type of a data source and usually ask you to kind of mention some type of statistic from that table, or in previous one, we had multiple tables we could choose from. So each of those, your initial post, and then kind of tying in your response to the data is both worth 5 points for a total of 10 points. You then also need to do what? Respond to 2 other students, each one worth 5, you get a total of the 20 points, right? So as the same for every single Canvas discussion, I'm reiterating that. I updated the language to kind of remind you of that, and that's due at the end of the day tomorrow, okay? Excuse me. I also had the Module 8 quiz. This must have just been me when I'm kind of changing the points. I must have accidentally hit the down arrow on my keyboard, and one of the questions was worth 1.25 instead of 1.5 points. So the scores were looking a little bit weird. I updated that this morning, so every question should have been worth 1.5 points. So you might have seen kind of your score update or change a little bit because of that, okay? Other than that, I put up an announcement this morning. I had a CL leader who is not going to be able to do their CL sessions this week. So 2 locations will be canceled and times will be canceled tonight. So I put that up in the announcement on Canvas, and then there will be 1 location on Monday, 1 time and location not available. Once again, all times and locations still have multiple time slots. So just kind of make sure you're checking this announcement if you're planning on attending one of those. The Fine Arts building at 5:20 and the 203 room at 6:30 won't be available tonight. Every other session is still kind of good to go. Those will be the only ones that won't take place on Thursday. And then the only one that won't take place on Monday is the one in Ballantine, 227 from 6:30 to 7:20. You should be able to see those. If you go to the homepage, it should have the announcements at the top. Or if you go to the announcements, it's the most recent announcement I posted. Okay? Other than that, what will pop up after class today? The Module 9 quiz. We'll do the end of the day on Monday. We won't have a module reading this week because what do we have next Thursday? The second in-class midterm, okay? So I've got that practice exam out there. It's been there for a while. Bring questions to class on Tuesday because we're primarily just going to be doing review, okay? So I want to make sure that's as effective as possible. The more questions you guys bring, the more efficient that's going to be, okay? Otherwise, I'm trying to guess what you aren't having a good idea about, okay? Other than that, I think that should take care of all the housekeeping stuff. I will put up an announcement later today. I'm still kind of waiting to hear back an email. Let me see. I might have just gotten it right now. Okay, I didn't. But I think I'll be in my office from 10 to noon tomorrow for some additional office hours. I'm not sure if I'll be in here as early as 10, so it might be 11 to 1. So keep an eye out on the announcements for exactly what that time will be. I'm hoping it's from 10 to noon. But I'm still waiting on an email about a scheduling conflict I might have. If I have to kind of push that forward a little bit to be like 11 to 1, I'll put up an announcement kind of confirming exactly what time that will be. Like I said, hopefully when I get back to my office, I've got an email waiting for me. Otherwise, as soon as I know later today, I'll kind of get that posted, okay? Also, I had some people stop by yesterday. If you ever come to office hours, if my door is shut, I do the virtual one. Sometimes I just shut it to kind of close out noise if I'm meeting with someone via Zoom. If it's during office hours and my door is shut, just knock. I might be in there. I might just be on Zoom with someone, or I might just be trying to close out outside noise if there's nobody waiting out in the hall, okay? Otherwise, I think that should be all the housekeeping stuff. We'll kind of pick up in Module 9 unless I've got any questions before we get going here. Okay, so that exam next week will look very similar to the first one. It'll be over the last 4 modules we've covered since the last exam. So modules 5 and 6 we combined to 1, modules 7, 8, and 9. All right. In class, full time will be available. 25 questions. Might be nice and give a bonus question, but it'll look very similar to kind of the procedure of what we had for that first exam, okay? I say similar, it's exactly going to be the procedure that we had for that first exam, okay? So, if there's no other questions, or no questions, we'll jump into material here. Yeah. Yeah, it's a good question. So I'll probably talk a little more about the exam on Tuesday, but this exam 2 equations, this will be part of the exam, so you'll have these to reference in the actual exam, which is why I kind of put it up here. They should be pretty basic, and a lot of them, as long as you're kind of reviewing and studying for the exam, a lot of them you probably won't need to check, and we'll go through a lot more of them. Most of them come from today's lecture, so I think it'll be a little more obvious kind of what those are after today. Yep. Okay. All right. So we left off last class talking about firms' production decisions, right? And firms' what marginal costs, right? Is where we kind of ended things, right? So we said, as a firm produces more and more, what's going to happen to their marginal costs? Well, we said it's directly related to the workers they're hiring, right? So we had this setup where we said, okay, as a firm is hiring more and more workers, just kind of reviewing a little bit where we left off. If we're thinking about the output or quantity that those workers were bringing in, what was true about the marginal product of labor initially? We said initially I'm going to get gains from specialization. So my marginal productivity of labor curve was actually increasing, right? Each worker was actually more and more efficient because I can now have them specialize on tasks. Now, eventually we get to a point where what started to take over? Diminishing returns, right? I no longer can have my workers specialize. I'm just hiring, or at least it's been overshadowed by, I'm hiring less and less effective workers, okay? Now, if I wanted to put a dollar amount to this, my marginal product of labor, the value or the worth to the company would be however many units that worker added times whatever the price I could sell them for, right? We kind of think about that was representing the marginal benefit to these companies. We said, what was the marginal cost of a worker? Their wage, right? So we said, all right, if the wage rate is the same, when I hire that first worker, that wage really represents my marginal cost. It must have been that the value of what that worker brought in was above the additional cost to my company. Well, if I've got gains from specialization, what should be true about the difference between that marginal benefit and marginal cost? If my workers are becoming more effective or more efficient, I'm paying them the same amount, that gap is going to be getting larger. So if I hire the first, I'll definitely hire the second, definitely hire the third, etc. Now, eventually, I start to get to a number of workers where past this point, what's true about the value of the additional output relative to the additional cost of hiring that worker? It is lower. So if the marginal benefit to the company is lower than the marginal cost, are they going to want to hire these workers? No. So we know that the optimal number of workers will always be somewhere on that diminishing returns to labor portion of the curve. Okay. Now, we also talked about there's a direct relationship between our workers' productivity and our marginal costs. So if I'm paying each worker the same amount of money, initially when my workers become more effective because of gains from specialization, well, if I'm paying the same amount per worker but getting more units, what's happening to my costs? Per unit, my costs would be getting smaller. So whenever we had gains from specialization, our marginal costs were decreasing, right? And once I start to have less and less effective workers, I'm paying the same amount for a worker, but I'm getting less additional units than before. My per unit costs or my marginal costs are going to be going up, right? So my marginal cost curve had the exact opposite shape of that marginal product of labor curve. I always say it kind of looks like a Nike swoosh, right? I kind of drew it looking more like a U here, but when we actually start drawing this out, this gains from specialization portion will probably be a lot smaller than that diminishing returns portion where we start to see it increase, okay? So what was true we said about our supply curves? Supply curves represent what? We don't know this going into the exam. It's going to be a problem. Supply curves represent marginal costs. So we typically draw the marginal cost curve as increasing. Technically, that supply curve or that marginal cost curve for the firm will actually look something like this. We just only focus on the diminishing returns portion where marginal costs are increasing because we know the optimal amount of labor is going to be somewhere over on that portion, right? But we know that our marginal cost will always kind of have this like check mark looking like shape to it, okay? Initially, it's decreasing because of gains from specialization. Eventually, it's going to start increasing because of diminishing returns to labor. Okay. All right. Any questions on this idea before we keep moving? So we kind of talked about this last class, so I'll probably go through this a little bit quick. But in general, we think about as I produce more units, my marginal costs are increasing, right? Now, kind of what do firms care about? We said the value of their output, so we multiplied that marginal product of labor by price. We then kind of connected that marginal product of labor curve to that increasing, kind of initially decreasing and then increasing marginal cost curve, okay? So our cost curve, our marginal cost curve came from what we talked about with the productivity of labor, okay? So we're really going to focus on today our firm's costs. So there's a little bit of kind of reviewing what we kind of finished with at the end of last class. With this idea of marginal cost, we'll talk about some different type of costs and then connect it to what we talked about last class. So if I am producing a number of units and I have a cost that does not depend on how many units I produce. So if I produce 100 or 1,000, that same rent on my building, doesn't matter how much I produce, it's still $1,000. We would call that a fixed cost. It doesn't change on my production decision. Or what do we call that last class? Fixed costs would be sunk costs, right? They don't change with my decision-making process, right? They are what they are. It doesn't matter if I produce 0 units, 100 or 1,000. So we can think of our sunk costs are really like our firm's fixed costs. They don't depend on our production decision. Now, as I produce more and more, what do I have to do? Hire more workers, or I have to pay for more raw materials. These things, as I increase production, if those costs are also increasing, we would call those variable costs, right? They are changing with my production decision. So firms have 2 types of costs, fixed and variable, right? If we add them together, we get total costs. So we're just breaking this down to 2 categories, okay? So nothing too crazy here yet. And I kind of alluded to this a little bit last class with the idea of like sunk costs. And then we had things where if I'm increasing my production, I have to hire more workers. Workers were really our variable costs there, okay? So if we think about the shape of these cost curves, if I fill out this column, and we don't have a specific value here, but what's going to be true about the fixed cost column? At every single quantity, my fixed cost should be the exact same value. Doesn't depend on my production decision. So here I think I chose 100, right? My fixed cost of production, whatever example this is $100. Now, as I start to increase my output, what's going to happen to my variable costs? Well, if I want to produce more burritos at Chipotle, I've got to buy more food. I've got to hire more workers. So my variable cost should be increasing, right? Now, don't worry about kind of why it has this little like shape here. It's going to be related to the fact that we had gains from specialization, but we won't dive into that in this course, right? So all we need to think about is that at every point here, my variable costs are increasing as I produce more units. Now, if I plotted my total cost curve, my total cost is just the sum of my fixed and my variable costs. So my total cost curve should look exactly the same as my variable costs, but at every point, it'll be how much higher, at every point, it'll be how much higher? Whatever the fixed cost is, or $100, okay? So total cost is just the sum of fixed and variable, okay? So if we then want to think about calculating marginal costs, right? If I had my total cost column, how did we say last class we calculate marginal cost? Well, it's just like anything on the margin. It's the change in that thing. So marginal cost would be the change in my total cost divided by, well, why were my costs increasing? Because I was producing more units. So a change in my total cost divided by a change in quantity, right? We had that from last class, right? So there's a change in total cost divided by the change in quantity. When I keep that change in quantity to be nice and easy, like 1, right? What was the marginal cost of my first unit? Well, the change in my total cost was 70, divided by a change in the quantity of 1, that's 70. Going from 1 to 2 units, change in my total cost is 50, divided by a change in quantity of 1 is 50. So what's initially happening from a quantity of 0 to about, what, 3? My marginal costs are doing what? Going down, right? They're not the same, right? My marginal costs, as I go from 0 to 3 units, my marginal costs are decreasing, which means I must be on what portion of the marginal product of labor curve? My costs are going down, my workers must be more effective, or I've got gains from specialization. As soon as my marginal costs start to increase, so past that quantity of 3, my marginal costs are increasing. Well, if my costs are increasing, my workers must be becoming less efficient or productive. So I'm on what portion of the marginal product of labor curve? Diminishing returns. Right? So we can get all that information just from looking at the directional change in our marginal cost. Okay. So marginal cost is the change in total cost divided by a change in quantity. Skip ahead here so I can get the picture. And it's going to look like this Nike swoosh symbol, right? Kind of a small portion where it's initially decreasing because of gains from specialization. Then it starts to increase because of diminishing returns of scale. Okay? Or diminishing returns of labor, sorry. Okay? Any questions on anything there before we keep moving? All right. Now, if I wanted to also calculate this, I'm going to skip ahead a little bit, I think. Well, I'll go back. Here we go. So I have my marginal costs. If I didn't give you total and fixed costs here, why could you calculate marginal costs from your variable costs as well? Well, anytime I increase production, what's the change in my fixed costs? 0. It doesn't change, right? It doesn't depend on my production decision. So where are all of my change in the total cost coming from? Changes in my variable costs. So notice if I use my variable cost column, what would my marginal cost be from 0 to 1? Variable costs are changing by 70, quantity by 70. Changes in my variable cost from 1 to 2, the change is 50 over the change in 1, 50. I would get the exact same values if I look at the change in my variable costs or if I look at my change in total costs. And that's because the only change in costs are coming from my variable costs. Okay? So we might use this idea a little bit later, but for now, we've kind of got our marginal cost curve, right? We're now going to start to talk about averages, okay? So this is where the formula sheet, you start to see some equations that we'll use today, okay? So if I've got my average fixed cost, the average anything is taking the total of that thing and dividing it by whatever quantity we're producing. How do you find an average? You add up the number of numbers you have, you divide by you add up all of your numbers and you divide by the number of numbers you have. All we're doing is adding up the cost of every unit and dividing by the number of units we have. So our average fixed cost would be our total fixed cost over quantity. And eventually we'll start to talk about our average variable cost is our total variable cost over quantity, and our average total cost would be our total cost over quantity. All right, this is how we're finding our averages. Right? Kind of think about it as like our per unit total costs, our per unit variable costs, and our per unit fixed costs. Well, as I increase my production, what's definitely going to be happening to my average fixed costs? Well, as I increase production, what happens to my fixed costs? They're the same. But if I'm spreading them out over more units, if my denominator is larger, what's happening to this average? The numerator is the same, denominator is larger, my average is going down. I'm spreading out, like this is the idea I mentioned, like Amazon has this huge web-based infrastructure that costs a lot of money. It's a huge fixed cost, regardless if they sell anything or not. Well, how can I spread that cost out over more units? I have to produce an insanely high number of units, right? So I've got this huge fixed cost. As I increase my output, what am I doing to my per unit fixed costs? They're always going down, right? So my average fixed costs, I would have kind of something that looks like this. What are they getting closer and closer to? A value of 0, right? I mean, theoretically, if I could produce an infinite amount of units, what would my average fixed cost be? 0. Right? Now we can't produce an infinite number, right? The more and more I produce, I'm getting closer and closer to 0. Okay. Any questions on this idea? Yeah, if I take the same value, but I divide it by a larger number, what's happening to this fraction? It's going down, right? So if my average fixed cost, the total fixed cost is always the same. It was 100 in our example. So if I divide it by larger and larger quantities, what's happening to my average? It's going down. So my average fixed cost is always decreasing. Yep. And we can kind of look at this numerically as well, right? If I take that fixed cost of 100 and at every unit I divide it by the quantity, 100 over 1 is 100. 100 over 2 is 50. 100 over 3, 33.33 repeated, so on and so forth. What's happening to my average fixed cost? Same $100, but I'm dividing it by a higher and higher number of units. My average fixed cost is getting lower and lower, right? So we know our average fixed cost will always be decreasing, okay? We kind of already had this drawn out. Okay. Any other questions on this before we keep moving? So hold on to that thought, right? We're just talking about fixed costs for right now, okay? So let's now think about variable and then total costs, right? So my average variable costs, right? There it's not quite as easy, right? Because initially, what's happening, my variable costs, they're always going up, but the rate at which they're changing varies. So if I went through and calculated my average variable costs here, what would I do? I would take my total variable cost and divide it by quantity. So 70 over 1 is 70. 120 over 2 is 60. 160 over 3 is what? 53.33 repeated, right? So on and so forth. So notice what's initially happening to my average variable cost curve. As I produce more, it is decreasing. But then once I get to a quantity of what, 4 here, if I produce past that point, what does my average variable cost curve start to do? Increase, right? And that's because eventually I'm hiring more and more inefficient workers, or I ended up being on that diminishing returns to labor portion, okay? So what our shape of the average variable cost curve is going to look like is kind of this U shape, right? So we're going to have initially it's decreasing, because I'm taking my variable costs and I'm spreading them out over more units, just like with fixed costs. But unlike fixed cost, my numerator isn't staying the same. As I produce more, my variable costs or my total variable costs are going to be getting higher and higher, and they're increasing at an increasing rate, right? So I'll have this kind of nice U shape to my average variable cost curve, okay? If it, the math behind it is a little tricky, all you have to do is calculate these values and understand that we're always going to have this U shape to our average variable cost curve, okay? Now, if I'm thinking about my average total cost, what's going to be happening, right? So we're going to break this down. I'll give you a slightly different way of thinking about it. Probably go through the slides a little bit quicker. But if I've got my average variable cost curve, and we just said it has U shape to it, right? My total costs are the sum of my total variable and my total fixed, right? If I just divide everything by the same thing, do I change the equality of this equation? No, right? So if I divide everything by Q here, what do I actually have? My average total cost is equal to my average variable plus my average fixed, right? So what's the difference between my average total and my average variable costs? Well, how am I getting my average total? I'm taking average variable and I'm adding my, so the difference between these two things is my average fixed. Well, what's happening? So initially, maybe my average total cost, as long as my fixed costs are anything, so right now we're assuming we're in the short run. But I can't change my building size overnight, right? There's some things that are fixed. I have some fixed cost. My average total will always be greater than my average variable cost because it's my average variable plus something, right? Plus those average fixed. But what's happening as I increase quantity to my average fixed cost? We said it was going down. So what's happening to the gap in between average variable and average total? Well, if the difference is my average fixed and it's going down, the difference between average total and average variable costs is getting smaller and smaller and smaller. Theoretically, if I could produce an infinite number of units, we said our average fixed cost would be, it's kind of weird, we can't produce an infinite number of units, but it would be 0. So if I could produce an infinite number of units, what would be true about my average total and average variable? They would be exactly the same. Now we can't, once again, we don't get to an infinite number of units, but as we produce more and more, that difference gets smaller and smaller and smaller. Okay? So this will always be the relationship of average total to average variable cost, or this will always be what the firm's average total and average variable cost structure looks like. Okay? Everybody with me on this idea? So just to give some support to this, I could go through, how do I calculate average total? It's the total cost divided by quantity, right? We said anytime I want an average, I take that type of cost, whether it's average total, average variable, average fixed. So average total, I would take the total cost and I divide it by quantity. So here I would have what? 170 over 1 is 170, 220 over 2 is 110, 260 over 3 is what? I was something less than 175, no, 86.67, et cetera, right? So I could calculate my average total cost. Now, what ends up being true? What should be the shape of my average total cost curve the way I drew it? It should also have this kind of U shape, or initially as I'm increasing output, what's happening to my average total cost? It's going down, but eventually I hit a quantity where my average total cost, because I'm hiring more and more inefficient workers, it will start to increase, right? Past that quantity of 5, increasing my production will actually increase my per unit or my average total costs. Right? Another way to think about average total costs are like my per unit costs. Okay. Now, if I had my average total or my average fixed and my average variable, we had those in the previous slides. What should be true? My average variable plus my average fixed should always add up to my average total. Right? And what's happening to that difference between average total and average variable? Well, because that difference is my average fixed, it's getting smaller and smaller and smaller, right? Or these two curves, right? That gap is getting smaller and smaller and smaller. Okay? So I'm always going to have this kind of U-shaped average variable, U-shaped average total cost curve. The average total cost will always be the one on top because it includes my variable plus my average fixed costs. Okay? Yep. Right? That's why the gap's getting smaller, right? Because the difference is my average fixed, and what's happening to my average fixed? It's getting smaller and smaller as I produce more and more units. Yep. Any questions on, any more questions on this before we keep moving? Okay. So I threw in the marginal cost curve here. I'll kind of give you more of a reason why I put it where I did. So we'll think about this relationship now of our marginal cost to our averages, okay? And we kind of already talked about a similar concept last class, and I'll just use the average total initially to make this point. So anytime I'm drawing out my average total cost, I should kind of have this U shape to it, okay? Now, my marginal cost curve is going to look something like this, okay? It'll always start out well below my average total, and that's the reason is because in the short run, I have these fixed costs, okay? Anytime well, color code this. If my marginal cost is below my old average, well, if I'm adding a value to cost and it's below the old average, my new average must be, so if you have your current grade and you do worse on the exam, your new average is going to be lower, right? So when the marginal cost is below the old average, my new average is going to be decreasing. right? And then at any point past this, my marginal cost is what? Greater than my average total. So if I'm adding a value that's above my old average, my new average has to be higher or increasing. That's how averages work, right? I have an average of 50 and I add the number of 60 to those old numbers, my new average will be higher. Right? So what's going to be true? My marginal cost, because it's the change in that total cost, it's what's being added to that old average, it's always going to hit my average total cost at its minimum point. So my marginal cost will always hit the average total cost kind of at its minimum point. Okay? So I can kind of think about, I'll just call this QATC. That's the point where my marginal cost is going to hit that minimum point of my average total cost curve. So we kind of talked about a similar idea with marginal productivity of labor of the workers, but this is the idea. When the number I'm adding is below the old average, my new average has to be lower. When the number I'm adding or my marginal cost is above the old average, my new average is higher. Okay? So where would my average variable cost curve be here? Above or below my average total costs? Below, because my average total is my average variable plus my average fixed. What'll also be true, it's an average as well, and we said our marginal costs are only coming from changes in my variable costs. So the same kind of principle will apply whenever my marginal costs are below my average variable costs are decreasing. Anytime the marginal cost is above my old average variable, my new average variable will be higher. It's the same kind of principle as we just talked about with the average total. But because the average variable cost curve is always lower, it doesn't take into consideration fixed costs, my marginal cost will also hit my average variable at its minimum point, but that point will always be at a quantity that is a little bit lower than where it hit the average total cost curve. Okay? So here we're kind of getting at this relationship between marginal costs and my averages. I know it's going to hit my average total and my average variable cost curve right at their minimum point. Okay? Any questions on this idea? Okay. All right. Yeah. So we haven't talked about that yet. All right. So we'll hold off on that for 1 second. Okay. So all we want to know right now is that that marginal cost curve hits both the average total and the average variable at their minimum points. Okay. Now here's all of the equations I'm going to give you on the exam. Right. That'll be your kind of formula sheet. Right. So we've talked about the averages. We've talked about how to calculate marginal costs. This will be everything that we want to kind of use. Going back all the way to the marginal productive labor thing? Yes. Right, because we're paying each worker whatever the current equilibrium wage is. So that wasn't necessarily the marginal cost per unit. That was the marginal cost of a worker. Since we looked at that graph, what has always been on our x-axis? Not the quantity of labor. We're now looking at output, or the number of units we're producing, right? So that in that graph, we were looking at the marginal cost was the marginal cost of labor, or each additional worker costs us the same wage. We aren't factoring in right now at all kind of what we're just looking at the cost structure. We haven't talked about the marginal benefit of selling these units, right? In fact, we won't until we look at stuff after this next exam. Yep. Any other questions on anything kind of up to this point? So I would probably suggest I put the average fixed cost in here, but really, and I'll skip ahead here for a second because I know I've got it. Right. If you want to do a quick and dirty kind of sketch of what a short run cost structure looks like for a firm, draw a U-shaped average total cost, draw a U-shaped average variable cost that is below it. The gap should be between those two decreasing as we produce more, and the marginal cost will hit both of them at their minimum point. Okay, so this slide kind of right here. This is, we'll kind of revisit this. I already drew this out for us, right? In fact, before we do this, I'll kind of talk through it since I kind of jumped the gun a little bit, right? But we said initially we've got decreasing average total cost. They then start to increase. What'll end up being true? At the minimum point of our average total cost curve, that's going to be what we call our efficient scale of production. Because what does the lowest average total cost point represent? It's where our per unit costs are at their lowest. Just say it out loud. Where does a firm want their per unit cost to be? Lowest possible. So they want to be at that minimum point of the average total cost curve because average total costs represent per unit costs. Where will the lowest point of the average total cost curve be? Where the marginal cost intersects it, right? So we can identify the efficient point of production by where the marginal cost hits our average total cost curve because we know that will be the minimum point. What does a company want to do? They want to lower their per unit cost to be as low as possible. Now, the lowest point in our average variable cost curve, well, we don't really care about that because that doesn't factor in our fixed costs, and we still have to pay those, right? So we're wanting our per unit cost to be as low as possible. Now, after this exam, we'll start to talk about shutdown decisions, things like that. It gets a little more complicated. But for right now, we're just thinking about if the firm wants to choose that efficient point of production, it's at that lowest possible point of the average total cost curve. And that point will be where the marginal cost curve intersects that average total cost. Yeah, right. Notice where will the marginal cost, where will I always be at on the marginal cost curve when it intersects the average total cost? It's always going to be when the marginal cost starts to increase. If my marginal costs are increasing, what portion of the marginal product of labor curve am I on? I'm always going to be on the diminishing returns, which is going all the way back to where I said that's why we only draw supply as just the upward sloping point, because we know that efficient scale of production, what's going to make the most sense to minimize my per unit costs will always be on that increasing portion of my marginal cost curve. It's probably taking a little bit further than I asked you a question on, but yes, this is like a bigger kind of picture thing. Represents what? Yep. And I tried to draw this to scale, right? Does it look like this is the lowest point on that green curve? I mean, maybe visually it's harder to see from up there, but yeah, it's at the lowest possible point, right? And you can, so we went through this kind of on off the slides, right? That relationship between marginal and average total cost. You could also look at it on a table, right? So if I had these values, if I didn't have this nice visual where I can see the average total cost curve is higher, and here I had my jumps in quantity weren't just one, right? So I had some numbers. Really what we're trying to get out in this slide is this idea of what's happening to my average total cost curve and that relationship between marginal and average total cost. So notice initially, when I increase my production at these lower quantities, well, what should be happening to my average total? We originally start drawing it as it's decreasing. So as I increase production, what's happening to my average total costs here? And where are these coming from? I'm taking this, if I produce nothing, what would my total cost be? They should represent my fixed costs. I then add to those fixed costs of 10, my variable cost, that would give me my total cost. I then divide that by quantity, that's giving me my average total, okay? So initially my average total cost, as I increase output, what's happening to my average total? It is decreasing up into what? After that quantity of 45, it then begins to increase. It has this U shape to it. Now notice, anytime I increase production, so let's say I go from 20 to 35 units here, my new marginal cost, is it above or below my old average? Is 0.33 higher or lower than 0.75? Jesus. Right? We got to be able to compare these numbers, right? Is 0.33 greater than or less than 0.75? Less than, right? Sorry, I shouldn't have done that. But right, we have to be able to kind of compare these, right? This is like basic arithmetic, right? All we're talking about is it greater than or less than. So is 0.33 my marginal cost greater than or less than my old average? Less. So what's going to be true about my new average? It would be Lower. Sure enough, is it higher or lower? It's lower. It went down. I go from 35 to 45 units. What's happening? My marginal costs are increasing, but is my marginal cost above or below my old average? Is 0.5 above or below 0.57? Below, so my new average should be lower, right? Anytime my marginal cost is below my old average, my new average has to be lower. We can prove this on a graph, but what's behind a graph? Numbers, 2 columns, right? So we can look at this on a table as well. Past the quantity of 45, if I go from 45 to 50 units, my marginal cost is 1. Is that above or below my old average total cost? Above, so my new average should be higher, right? So we can prove this to ourselves using actual numbers on a table, but that's why we draw it out graphically the way that we do, right? Now here, if I'm asking you questions on an exam or a quiz, I probably would be a little bit more friendly, because where's the minimum technically? Where's the minimum point of my average total cost curve here? At what quantity? Well, where's the lowest value? 0.55. But is that where it's equal to marginal cost? No, I'd have to give you like every single quantity, make this a much larger table. So if I was doing this like on an exam or a quiz, I would give you something where you can identify a quantity where the marginal cost is exactly equal to the average total cost. That would be our efficient scale of production, right? But even here, I technically could say, like, if these were my only options, and this is like a little bit more like of a real world example, sometimes I can't produce batches of one. When I buy things from Temu, they're not making 1 unit at a time. They're making hundreds of units at a time, right? And so maybe that jump is somewhere in between 100 and 200. And so it really is technically wherever that average total cost is at its lowest point. There may not be a perfect equality between marginal cost and average total cost, but as close as we can get. But I'm not going to try to trick you with that like on the exam or a quiz question. I'd give you a point where they're exactly the same. I just wanted to have one here where we can see that's not always the case. Okay. So I kind of skipped this table here, but any other questions about kind of identifying this efficient scale of production, kind of from this table or graph? I mean, really what this comes down to, this is the drawing you want to have to understand that relationship between marginal costs and your average total and average variable costs, right? And you can always draw this out relatively quickly. 2 U shapes where the distance is getting closer and like smaller and smaller, they're getting closer and closer together, and that marginal cost hits them both at their minimum point. Okay. Any other questions before we keep moving here? Will the average variable cost curve ever intersect my average total cost? No. Why? My average total is my average variable plus my average fixed. So there always has to be some difference, because there's always going to be something that's fixed in the short run. I can't change everything overnight, right? So in the short run, I always have some fixed cost. So there's always a difference between those two curves. Yep. Excuse me. Good question. Any other questions we got here? Okay. Let me see where we're at. We're going to get to long run here. We got 30 minutes left. All right. I'll go through this kind of quick. So I'm going to go through this quickly. If I lose you at any point, this would be a good table to be able to go back and reproduce on your own. Okay. So let's say I gave you this information. This is where having this equation sheet and being able to kind of reproduce these, being able to kind of fill a table out like this. I probably wouldn't ask you to fill out like an entire table on an exam or a quiz, but I might ask you about specific points in this table. If we could solve for the entire table, I could ask you a question about any one point, right? So I'm just going to reproduce what I have in the slides. We're going to work through this, okay? So one thing that's kind of unique is, so I gave you what? I gave you 7. I gave you, 720, 740, 15, 202. Okay. If I'm starting out with a table like this, what column should be pretty easy for me to fill in quickly? What column has the same value? Fixed costs. Well, I didn't tell you what the fixed costs are here, right? So this is where another good point to start in a question like this. If I asked you about solve for me the average fixed cost of 2 units, or solve for me the total fixed cost of 4. Look at that quantity of 0. First of all, I can't divide by 0, so my averages I can't find here, right? If my total costs are 720 when I'm producing nothing, what are all of my costs when I produce 0 units? Fixed costs. My variable costs if I produce nothing are 0. So my total fixed costs at 0 units are only fixed costs. So once I know those, I can fill in. And these are 2s. I don't know why they look like that when I'm writing with a Sharpie. Sorry. So this is all 720, right? So once I identify the fixed cost at one quantity, I know it everywhere else, right? So now what's another really easy column for me to fill out? If I know my total fixed costs, what are my average fixed costs? Just my total fixed divided by quantity. So here I would do what? 720 over 1 is 720. 720 over 2, 360. 720 over 3, 240. 720 over 4, it's going to be what? 180 if I'm doing math in my head correct there. Okay. Any questions on what I'm doing there? Are you sure? Like I said, I know I'm going to go through it quick, but if you have a question, you can stop me here. So the fixed and average fixed cost column are likely going to be the easiest to do first, right? Now, if I know my variable costs and my fixed costs, what must my total cost be? My total costs are composed of 2 types of cost, fixed and variable. So if I want my total costs, I simply add these together, right? My total costs are just my total fixed plus my total variable, right? So what would I do here? If I know the total cost is 740, the total fixed is 720, what must my total variable cost be? The difference between those two, right? I'm using the same equation. I've just got 2 pieces of information, and I've got to solve for this third thing I don't know. It's just a little bit of algebra, right? So that difference must be 20, okay? Now here, how would I find my average variable costs? Simply take my total variable costs and divide them by quantity, right? Average variable cost would be total variable cost over quantity. So this would be what? 7 over 1 or 7, 20 over 2 or 10. We were given this piece of information. Okay, I don't quite have this yet. What else can I kind of figure out from here? Oh, well, if I know my average variable costs are 15 at a quantity of 3, how can I find my total variable cost? This is just a little bit of algebra, right? Multiply both sides by 3, and I end up with it must be that my total variable costs are 45 here, right? Well, now what are my total costs? Total variable plus total fixed, so 765, okay? Now, what's also going to be true is we said not only will the total cost be the sum of total fixed and variable, but our average total is our average variable plus our average fixed. So if my average total is 202, my average fixed is 180, what must my average variable be here? The difference between those would be 22. And then now it's just like I did before. Average variable cost is my total variable cost over quantity. Well, if I know the average is 22, I know my quantity is 4. It's just a little bit of algebra to figure out my total variable cost must be 88 here. Find my total. I simply add these 2 together. I'd be at 808. How do I find my average total costs? Well, once I have my totals, this should be easy. It's just take the total and divide it by the quantity, right? So I don't know, I'd have what? 727 here. I'd have, where am I at? So 350 plus 20, I think. No. Where am I at? So I've got total costs of, yeah, 740. So 370, 765 over 3. So this is going to be what? 250. Well, actually, how could I figure these out even easier? Yeah, what else could I do? Simply add up my average variable and my average fixed, right? So here, this would be what? 255, right? Just like here, I could have added these up to find 370. Okay? So there might be multiple ways to find some of these values, okay? So I now have every column except for one filled in, right? So I want to make this point kind of again. If I want to find my marginal cost, it's the change in my what? Total cost divided by a change in. What are my changes in quantity here? One, my life's a little bit easier, right? Now, if I didn't have any of these total costs, what could I also look at the change in? We said the only change in costs are coming from my variable costs. So I could look here. Oh yeah, the change in my total or in my total variable is 7 divided by a change in 1, so 7. Change in my total costs or a change in my variable cost here is 13 divided by a change in quantity of 1. Change in my total cost here is 25. Change in the variable cost was also 25. And then a change here, we've got what? 35 plus 8, so 43, right? So starting out with pretty limited information, just using those basic equations we had about how to calculate averages and the fact that our total cost was composed of variable and fixed, we could actually fill out this entire table. Yep. So if it went from like, let's say it instead, it was jumps of 10, what would happen to my marginal costs? Instead of 7, I'd be dividing by, instead of 1, dividing by 10, so it would be 0.7, 0.13, et cetera. Right? You're just dividing whatever that change in quantity is. Yep. Okay. So once again, I know we went through this quickly. I would be able to kind of reproduce this, right, on your own. Sit down with that original table and see if you can reproduce, right, on your own every single point in that table, or every single value, I should say, in that table. Okay. How do you find marginal costs? The change in total costs divided by the change in quantity. So all I was doing was looking at what was my change in the total cost, dividing it by the change in quantity. Here, that would have been 7 over 1. Yep. Okay. Any other questions before we keep moving here? So the marginal cost is the change in total cost divided by not my quantity, but the change in quantity. Here, my changes in quantity are always 1. Yep. Okay. All right. So we kind of talked through all of this already. We've got 20 minutes, so I want to try to hit on 2 more concepts, and I'll make the quiz kind of easy for us here. So we'll talk about that in here in just a second. But we're now going to move from the short to the long run. Right? It actually becomes quite a bit easier. Okay? So in the long run, we don't really have a definitive end. So it's just like from here to the end of time. So in the long run, what is fixed? In the long run, I could change everything, right? So in our long run, what does our average total and average variable cost become? The exact same thing. It actually becomes easier than in the short run, right? Because now our average variable cost curve is the exact same thing as our average total cost. All the same principles apply in terms of like the marginal cost will hit at its minimum point. It's going to have this nice U shape to it. Nothing's really changed other than we just don't have any fixed costs. Right? Now, where exactly would our long run average total cost curve come from? We can think about, okay, I can change labor, raw materials as I produce more units in the short run, but I can also change things now like building size. Okay? So I'll run through this example and then kind of give you a more continuous one. But if I'm thinking about here, I've got 3 different production facilities. If I think about, I'm currently in this small production facility. I'll start talking about average total costs represent what? Our per unit costs, and we want them to be as low as possible. So if I'm at producing quantities underneath QA here, if you were to draw these cost curves higher, do I want to be in the small, medium, or large production facility for quantities down here? Well, at every quantity here, the per unit costs are lower in that small production facility. Now, as soon as I get past QA, what production facility can I actually get to lower per unit cost? If I stay in the small production facility and I produce past QA, my costs start to increase. But in the long run, if I jump to instead a medium-sized production facility, I no longer see an increasing average total cost. My average total cost will still be decreasing. And then if I ever want to produce past QB, well, if I stay in a medium-sized production facility, my average total cost will start increasing. But if I jump to instead a large production facility, now I'm keeping my average total cost or my per unit cost as low as possible. So in the long run, as I scale up my production, just intuitively, am I going to want to choose higher or lower size production facilities? What's going to make sense? If I want to produce 1,000 more units, I'm probably at some point going to want to jump to a larger production facility, right? This is all this is telling us, right? So our long run average total cost curve will be the lowest possible average total cost we could get to, changing this fixed factor of production, right? So anywhere before QA, I'm going to want to choose a small production facility. I'm producing a low number of units. As I start to produce more units, eventually I want to switch over to the medium-sized production facility. It allows me to keep my average per unit cost the lowest. And if I continue to produce more and more, eventually I want to jump to this larger production facility in order to keep my per unit cost the same. Per unit cost as low as possible. Okay. So my long-run average total cost curve will be the combination of the lowest possible points of every single possible short-run average total cost curve I have. Because in the short run, whatever production facility I choose, I'm locked into that for a certain period of time. But in the long run, I can jump to different square footage production facilities, right? So what is this going to look more practical to? Like if we look at, because I don't just have the choice between 3 production facilities, it's going to look something more like this, right? I'm going to face a short run average total cost curve from choosing a certain size production facility here. I could choose a different size facility and then a different one, and a different one. I've really got like a whole bunch of different production facilities I could choose from. Well, the long run average total cost curve will just be the lowest possible point of all of those short run average total cost curves, right? So my long run average total cost curve will still kind of have this like U shape to it. It's going to be a little bit more disjoint than before when we're looking at the short run, but it'll still kind of have this U shape. So in the long run, where do I want to be? Where my per unit costs are at their lowest, so I still want to get to that minimum point of my long run average total cost curve. None of the principles that we talked about with the short run have changed at all yet, right? It looks the same in the long run. I've just got my long run average total cost curve. I can now change this fixed factor of production, but I still want to get to the lowest possible point on the long run average total cost curve, okay? Any questions on this idea? Okay. All right. So, right, we're going to talk about 3 portions. Right? I drew this out kind of like I've got a ton of different, square footage buildings I can choose from. Here's all of them. Here would be my kind of long run average total cost curve, the minimum of every single one of those short run average total cost curves. Initially, as I want to increase my quantity, right, what's happening to my average total cost in the long run? It's the exact same as the short run. Initially, as I increase output, my average total costs are going down or decreasing. What we'll call this is initially we're going to have what we call economies of scale. As I scale up my production, why might that be a good thing? Because I'm taking these huge fixed costs and I'm spreading them out over more units, right? It's the same idea in the long versus the short run. Larger buildings are going to be larger fixed costs in the short run, but I can spread them out over more units. So we're going to call this, as I scale up production, I have what we call economies of scale. I'm lowering my per unit costs. I'll skip this one for a second. Eventually I get to quantities, whereas I scale up production, well, I've now got, like, it's really expensive to build like massive buildings or build large universities, right? So what's true about a university like IU relative to like, I don't know, Ivy Tech? They don't have near as many students, so their buildings and their facilities are much smaller, right? Eventually we get to a point where as I'm increasing this fixed factor of production, what starts to happen to my per unit costs? They start increasing. We would call this diseconomies of scale. As I increase my or scale up my production, my per unit costs are going up. Now there will be this portion in the middle. I kind of exaggerated it and how large it'll actually be, which kind of corresponds to what we looked at earlier. This I'm going to call my constant returns to scale. So here, if I increase my production, what's happening to my per unit costs? They're actually staying the same. That's why we call it constant returns to scale. So what would be true? My efficient point of production is going to be somewhere on that constant returns to scale. So it's likely going to be like a very small range of quantities. I'm drawing it much larger here just to kind of have that visual. So our efficient scale of production will really be when we're on that constant returns to scale of our long run average total cost curve. And it's not going to be as large as I have drawn here. It's probably going to be like in between two specific quantities, right? So economies of scale, I scale up production, I'm lowering my per unit costs. Constant returns, I scale up production, my per unit costs stay the same. Diseconomies, I scale up my production or increase quantity, I'm increasing my per unit costs. And ultimately, it's the intuition that what does a company want to do? They want to keep their per unit costs as low as possible. All right? You have a question? So I didn't say that it was, right? Where did I say that we actually want to be at if we're choosing the efficient point? What portion of this long run average total cost curve will we be on? Constant returns to scale. When I'm on the economies of scale portion, well, then what do I want to do? I want to scale up my production because there are gains to doing that. Now, I'm not at the efficient point yet. I'm getting closer to it by scaling up my production, but I'm not on the efficient portion. The efficient portion will actually be when I change my production, my per unit costs are still as low as possible, or they haven't changed at all, right? I'm at the lowest. You know, here I've got several points that are at the lowest, but I'm at least on one of them, right? These will be my efficient quantities of production when I'm on the constant returns to scale. So when I'm on the economies of scale, what do I want to do? Increase production. That's how I can lower my per unit costs. Once I end up on the diseconomies of scale portion, what do I actually want to do so if I want to lower my per unit costs, if I'm on this portion, what do I actually want to do? Decrease my production or scale down my production to move to that minimum point. Is that? Any other questions here before we keep moving? Okay. So, just to kind of be more practical here, I'm going to publish the in-class quiz just so you get it pulled up, and we'll kind of talk about it at the very end of class, but so that it makes it a little bit easier to kind of get it submitted in time. Here, let me make sure I've got the time set correct too. Yeah, so we've got 5 minutes after class. So we'll have a little bit of time, make sure you can get it submitted before you head out of this building. The number today is 79.25 will get you into that quiz, okay? So I've got one more topic, and then we'll visit this quiz at the very end of class, okay? So I'm trying to give you a topic here that's going to be some softball type questions on the quiz this week, but also the exam, right? So we are only going to care about a couple things when I talk about identifying the type of market that we have. So after the exam, we will talk in detail about each of these 4 types of markets: perfectly competitive, monopolistically competitive, oligopolies, and monopolies. Okay? All we want to know right now is all of them have different levels of what we call market concentration, or if it's a perfectly competitive market, it's very competitive. If I have a monopoly, you've probably played the board game or you've heard it mentioned, a monopoly means how many firms are there? 1. Is that going to be a competitive market? That's the least competitive market, right? So we're going to have 2 measures that we want to measure market concentration with, right? Or how competitive a market is. The first will be the 4-firm concentration ratio, right? So the 4-firm concentration ratio is just taking the market share as a percent of the top 4 firms and adding them together. I hope you agree. These should be easy questions, right? So if I'm looking at something here, this would be even more complex. But if I were to just give you an example like this, what are the top 4 firms? I give them to you here. What would their market share be? All I would do is look at the percent market share of those top 4 firms, add those numbers up. That is your 4-firm concentration ratio. Now here, because I throw all other firms in this catch-all category, if all other firms only have 0.1% of the market share, what must the top 4 firms have? 99.9. If I ever have 4 firms or fewer, what will my 4-firm concentration ratio be? If it's the sum of the market share of the top 4 firms and I only have 3 firms, they're going to have 100%. What if I only have 1 firm? 100%. So we have a problem. The 4-firm concentration ratio will allow us to identify if markets are more or less competitive, but once it gets to where I have less than 4 firms, 4, 3, 2, or 1 firm, it's all going to look the same, right? Now, what if I have, say, 100 firms and they're all splitting up the market share evenly? Well, then each firm would have what? 1%. So the top 4 firms would have, everyone has 1%. If I take the top 4 firms, it would be 1 plus 1 plus 1 plus 1, or 4%. So the lower this market concentration ratio, the more competitive that market is. The problem is at the high end, I can identify if it is 100%, but I can't tell you if it's a monopoly market or if there's 4 firms maybe that each have 25%. And those are very different levels of competition, right? So I can look at some industries out there and I can see, okay, automobile industries, more competitive. The top 4 firms have a smaller market share than, say, soft drinks industries, right? But when I look at the top end, I can't tell you if the tennis ball market or video game console market is any more or less competitive, because it could be a monopoly, or it could be that there's 4 firms splitting it evenly, 25% each. So the next kind of market concentration ratio we'll have is what we call the Herfindahl-Hirschman Index, or the HHI. Okay? All we're going to do is go through every firm in that industry, take their market share as a percent, square it, and then add them up. Okay? So if I had a monopoly, what would the market share be? What percent of the market would one firm have? If it's a monopoly, there's only 1 firm, they would have 100%. What would my HHI be? 100 squared would be 10,000. But what if I had a 2-firm industry where they're both evenly splitting it? Well, each one would have a market share of 50%. So the 4-firm concentration ratio in that market would still be 100. But what would the HHI be? No longer 10,000. 50 squared is what? 2,500 plus 50 squared, another, so it would be 5,000. So the HHI actually allows me to differentiate between a monopoly and a market where there's 2 firms evenly splitting that market share, right? So the HHI is going to be a little bit more of a useful measure of market concentration because it allows us to distinguish between markets at the top, okay? So I could kind of run through that same example instead of the 4-firm concentration ratio. What I would be doing is going through not just the top 4 firms, but every firm here, squaring their market share percentage and adding them up. So when it comes to the quiz or the exam, especially on the quiz this week, I'm likely just going to ask you about 4-firm concentration ratios and HHIs of monopolies. So a monopolist 4-firm concentration ratio is what? 100, their HHI would be, we said 100 squared is 10,000. Write that down. Might be good to have on the quiz. Okay? So next week, we'll kind of work through more examples, right? And we'll kind of dive into this deeper. But we can kind of think about, what if I had a market that looked like this? What would my 4-firm concentration ratio be? There's only 3 firms here, so it has to be 100%. If I wanted the HHI, how would I calculate it? I would take 37, square it, add to that 20 squared, add to that 43 squared. That would be my HHI, right? So as my HHI gets smaller, that's representing that I have a more competitive market. The higher it gets, it's getting closer to the HHI of a monopolist, which would be the least competitive. So your HHI will always be somewhere between 0 and what value? 10,000, right? The closer it gets to 0, the more competitive of a market you have. So if I looked at this market, it's a little bit tricky because this category is others. So what would the 4-firm concentration ratio of this market be? 36 plus 15 plus 12 plus 1, or what, 64%? Now, what would my HHI be? Well, this is where I wouldn't give you an example like this, because what would I technically need to do? Break down the market share of every other firm in that catch-all category. So if I gave you something like the automobile industry, I won't give this to you on the exam or quiz, because I'd have to go through and square every single one of these market share. It's going to take quite a bit of time. But I might give you one where I give you 3, 4, 5 firms. You can square each market share, add them up, and that shouldn't take too much time, right? And then also just basically understanding that as I see higher 4-firm concentration ratios or higher HHIs, that represents a less competitive market. The closer to 0 both those measures are, that would represent a more competitive market, right? So that's kind of what all I expect you to know in terms of the HHI 4-firm concentration ratio, how to calculate them, and then what those directional changes mean, right? Being higher means less competitive, lower would mean it's a more competitive market, okay? Any questions on this idea before we keep moving here? So before we get very excited, right? So everybody into that quiz, that number worked for you, 79.25. Oh, did I not publish it for you? Or is this just not refreshed? Hold on. Sorry. I thought I clicked publish as we were talking about it. Nope, that's the quiz. Hold on. I don't want that out there yet. Sorry. I do have the in-class quiz right here, right? I'll post that when I get back to my office. So all I want you to do to earn full points for today, you don't have to get the answers correct. I will adjust them when I get back to my office. Respond to every question here, right? So put a response in for question 1, 2, and type any number in for 3. I will go back, and as long as you have a response, I will give you full credit, right? Now, you will be able to see the correct answers after the fact, so you have some additional questions that would likely be good to review, right? Ran out a little bit of time. I wanted to make sure we focused on talking about some of these things. The HHI examples, because I know those questions will be a little bit easier if I give you those on the quiz this week. So just making sure you're getting a response in for every question. I have the due date set to be 5 minutes after class ends, so just make sure you're getting it submitted before you leave. There's also one more thing I'm going to tell you that might be helpful to you. You want to be quiet for a second? Okay? So is everybody with me on the in-class quiz? All right? So I'll adjust it once I get back to my office. Might take the next 20, 25 minutes for those to change on Canvas. This week's quiz, I gave you 2 questions at the end that are completely freebies, right? I'm asking you opinions about the exam, so they should be, as long as you respond, you will get points for questions 11 and 12. Now, I had to, because it's a graded quiz, have a correct answer selected. So initially, it might show you that you didn't get full credit for those questions. After the due date passes on Monday, similar to like what I'm going to do for this in-class quiz, I will go in and update everybody's score on Tuesday to give everybody full credit for questions 11 and 12. But until that due date passes, I can't do that. Okay, is everybody clear on what I'm saying? But you must respond to those questions to get the full credit after the fact, okay? So they are opinion-based questions. There is no right or wrong answer, but you need to respond to them to earn the points, okay? Everybody with me on that? All right, have a fun, safe weekend, and I will see you guys on Tuesday. Yep.